Your Java program is due soon, but you haven't written even a single line of code. You're already under a lot of pressure as the deadline approaches. At this stage, you can't ignore compact code without wasting valuable time. Replacing a few lines of code with just one could mean the difference between an early and late assignment. Now that we better understand the basic structure of loops, let's move forward to the first type, for loops. Let's introduce its simple implementation. Although there are many types of loops, for loops are notable for its concise structure. It can be easily implemented in Java by typing the keyword for, followed by a pair of parentheses and curly braces. Within its parentheses, for loops combine three steps: initialization, condition, and change, all into a single line. Remember that these statements are separated by semicolons in the parentheses. As for what's within the curly braces, there are unlimited possibilities. This is where we put code we want to iterate or repeat. It's also known as the body of the loop. Behind the scenes, for loops undergo a unique process for iteration. The first step of three is always initialization, which you can see at the start of this flowchart. Here, we declare or initialize a variable. This is done only one time. In my code to the right, I've declared a new int variable named I and initialized it as 0 to serve as the for loop starting point. Once this step is executed, the for loop evaluates a condition. This step is very similar to if statements because it returns a Boolean value. In the same example, the condition is listed as I is less than 10. It returns true when the value of variable I, which was initialized in the first step, is less than 10. In general, if a condition evaluates as true, the for loop continues into the body of the loop and executes its code. If it's false, the for loop immediately terminates and skips over the code of its body. Every time the code inside the for loop's body is carried out, the third step, change, executes. This change refers to the incrementation or decrementation of the variable we initialized in the first step. Going back to my example, if we put I++ in this section, the int variable I increments by 1 whenever the condition evaluates as true. Similarly, I plus equals 1 or I equals I plus 1 would do the same exact thing. Until the condition returns false, the for loop continues its iteration process by continually executing its body's code and updating the value of the variable, as long as I is not greater than or equal to 10. The for loop does not terminate. In fact, if you trace the for loop in my example, you'd find that the code in its body iterates 10 times in total, as I increases from 0 to 9. In another example I'll show you on my text editor, let's say you wanted to print out hello world 10 times. Obviously, you could type system.out.println hello world, and then copy paste this 10 times. If we go to our terminal window to compile and execute our code, the task of displaying hello world 10 times is done. However, this is just inefficient. What if we wanted to print this out 100 times or even 1,000 times? Now that you know for loops, try pausing this video and see if you can type a for loop that can print out hello world 10 times. To start a for loop, remember to type for and then 2 parentheses. Within these parentheses, type your initialization int I equal to 0. Then a semicolon. After that, type your condition, I is less than 10. And then finally, your incrementation, which is I++. Then, after the parentheses, type 2 curly braces where the repeated code will be contained. In this case, we want to repeat the statement system.out.println hello world. Just to show how the variable I is changing, I'm going to print out I as well. If we compile and execute the code now, we will get 10 hello world statements along with the step numbers in the for loop. As you can see now, in the terminal window, I started at 0. Then it checked if it was less than 10, and since it was, the computer ran the system.out.println statement. After that, I incremented itself to 1, and then the process started again. Then, I became 2 and 3 and so on until I became 10. That's when the condition failed and the computer stopped the for loop. Understanding for loops is crucial for simplifying your code, especially when you're on a time crunch. Once you get the gist of its process, you can implement iteration without redundancy. Remember that we just need initialization, condition, and change. And of course, you aren't just limited to for loops in Java. Let's move on to another type, while loops.